Hi everyone, in today's video we'll be looking at how to find an unknown shortest side using trigonometry. So for question 4 from exercise 803 from Ex8.03 Maths, find each length or distance correct to one decimal place. For part A, how far the person is from being directly under the birds. So there are birds here at the moment, and there's a person here which he has a height or she has a height of 187 centimeters, and we're trying to find out this distance here, which is the horizontal distance. Okay. So if we have a look at this triangle here, okay, the sides that we have are D, which we don't know, but we don't have also this one, okay? So this distance here is just a portion of this. So if I want to find out what this distance is, I need to get this whole entire distance to the 2,450. I need to minus this distance here, which is 187. So if I was to get now that distance, that is 2,450 minus 187. That would give us 2,263. Okay, that's in centimeters. So that means that if the person was standing here, then from his head all the way to the birds, that would be the total distance. That's the vertical distance. And now in this triangle, okay, if I was to redraw that out right here, you will now see D being this bottom distance here. We've also got an angle of 62 degrees, okay, which the person's looking up at the birds at, okay, right there. And this distance here, which we just found, was 2,263 centimeters. Now, if we're trying to find D here, first to analyze where is our hypotenuse, adjacent, and opposite side. Well, our hypotenuse is the longest side opposite the right angle there. The adjacent side is the one just right beside the 90-degree angle and 62 degrees. Opposite the 62 degrees is our opposite side. Okay, so now we want to find out this, okay, which is our adjacent side, but we're given our opposite side. So using our mnemonic SOHCAHTOA, we can see that the part of the mnemonic which has opposite and adjacent is TOA. So that represents the tan ratio. So the tan ratio of 62 degrees, okay, according to this angle, is going to be the opposite side, which is 2,263. That's the opposite, over our adjacent, which is D. Now, from this point onwards, we have to choose whether what technique we have to do to find out what D is. Now, D or some unknown value can be on the numerator or the denominator. If it is on the denominator, all we need to do is switch these two values around, okay? So the D on the denominator and the term on the other side. So if we switch these around, we get 2,263 over tan 62. Okay, so 2,263 divided by tan 62, that will give us 1,203.258. But if I was to round this to one decimal place, that'll be 1,203.3 centimeters. Okay, that's what it says to do. All right, that's question 4A done. Let's move on to 4D. So here we have this roof. Okay, so it's a roof of a house here, okay, with that chimney there, you can see that. And we want to find the slant height of that roof. Now, when you use trigonometry, you always have to focus your eyes on one right angle triangle. Let's just say this one, okay, because W is there already. So we've given the 1,600 centimeters as stretching from one side of the house to the other side. We don't actually need that. We just want half of this. So half of the 1,600 is going to be 800. So we're going to write 800 centimeters there, right? Now, if I was to just redraw this triangle out for you to see, you can see now that in that triangle, we've got 800 here. Okay, there's our 90 centimeters, so 90 degrees, and 800 centimeters down the bottom. And we've got 40 degrees right here, as well as the W there, which is our slant height. Now, that W there is our hypotenuse opposite the right angle, 800 is our adjacent edge right beside the two angles here. So using our mnemonic SOHCAHTOA, the part which has A and H is CAH, and that represents cosine. So we're going to apply the cosine ratio of 40 degrees. That is equal to adjacent over hypotenuse, which in this case is 800 over W. And again, our missing value is on the denominator. If it's on the denominator, we switch this around with the value on the opposite side. So W would equal to 800 over cosine of 40. So 800 over cosine of 40 is equal to 1,044. Hold on, let me just write that better. W equals 1,044.325. Okay, and now to round this to two decimal places, this will be 1,044.33. Okay, this makes sense because this is the longest side of the triangle, so it should be bigger than this 800. There we go. Let's move on to question 5. Question 5 is our first question that doesn't have a diagram, so we're going to draw one. So a rectangular gate in this case has a diagonal brace that makes an angle of 60 degrees with the bottom of the gate. The length of the diagonal brace is 1,860 millimeters. Count the height of the gate. So if this is my gate, which is a rectangle, and I've got a brace here, which is basically the part of the gate which keeps it together and it's rigid. Okay, so it doesn't end up being, like this. Okay, so now we have to put our information here. So the information that we've got first is it makes an angle of 60 degrees, the bottom of the gate. Okay, so here's my diagonal brace. There's my bottom of the gate. It makes an angle here of 60 degrees, whereas the length of the diagonal brace is 1,860. So this is 1,860 right there. And this is a 90-degree angle on the bottom right side because it's a rectangle. So we're trying to find out the height. So this is getting us to find out the height of our gates. Okay, so let's label what these are. So here's my hypotenuse, obviously. That's our longer side. And this side here is directly opposite our other angle. That's not 90 degrees. So that's the opposite. So using our mnemonic SOHCAHTOA, okay, the part which has O and H in there represents the sine ratio. So we're going to use the sine ratio here. So sine of 60 degrees is our opposite edge, which is H, over our hypotenuse, the longer side. So that's 1,860. And this time we have something different to our last question, which had the unknown on the denominator. This time we have the unknown on the numerator. This is perfect. All we're going to do is we have to get rid of this 1,860. So because we've got that division of 1,860, the opposite of that will be multiply by 1,860. And once we do that to one side, we do it to the other. So these will cancel, leaving us with H being what this is. So I'll write that again. And if I then type that on my calculator, 1860 sine 60, that would give us H equals to 1610.80, so on. So the closest answer to this would be letter C. Right, let's move on to question 6. A ladder rests against the wall. The foot of the ladder is 355 centimeters from the wall and makes an angle of 63 degrees with the ground. How long is the ladder? So this is pretty cool. So we've got a ladder here. Oh, no, this is the wall here, sorry. And you know that there's a ladder that is leaning against the wall. So let's just say if I draw one right here. Okay, this is the ground. There's your ladder. Okay. Now, we can actually find out the length of this ladder as long as we know a couple of things. So in this case, in our question, we've got the foot of the ladder is 355 centimeters from the wall. So there's the wall, Okay, there's the bottom of the wall, and there's the foot of the ladder. Okay, so if this is the ladder, that's the wall, then this distance here is 355. Let's put that there. That is 355 centimeters. And it makes an angle of 60 degrees with the ground. So that bit there, that's saying the 63 degrees with the ground, that's very important. So we don't put it here, we put it here, since that's between the ladder and the ground. So we'll put that as 63 degrees right there. And another important thing is we should write that right angle there because we can only use trigonometry at the moment with our right angle triangles, right? So what are we finding here? The question says to find out how long, to correct to the nearest centimeter, is the ladder. So trying to find out this bit here. Let me just highlight that so you know. Trying to find out this, okay, that distance there. And so we'll call that maybe x. Okay, so what do we have? We have the edge that is opposite our right angle, and that's the hypotenuse along the side. We've also got the edge here, which is right beside, okay, or adjacent to our two angles. So we'll call that A for adjacent. So using Sokotoa, once again, we know that since we have A and H, that resembles ka, so that we have to use cosine ratio. So our cosine of 63 degrees would equal to our adjacent side, 55, over the hypotenuse. So we'll have 355 over x. And now we've got x on the denominator. So if we've got x on the denominator, we should switch this around with the terms on the other side. So if I do that now, if I switch this around, x would equal to 355 over cosine of 63. Okay, so x would equal to, let me just check that, and that is 781.95, so on. So if I was to round this correct to the nearest centimeter, that'll be the nearest whole number. So because that number there is a 9, which is above 5, I have to round this number here up by 1. That'll be around 782 centimeters. Okay? All right, let's move on to question 7. All right, 7. A glider is flying at an altitude, height of 1.5 kilometers. To land, it descends at an angle of 80 degrees to the horizontal. How far must the glider travel before landing? Give your answer correct to the nearest kilometers. So here's a picture of a glider, okay? So obviously in the word glider, there's the word glide in there. So the role of this plane is to just glide on like through the air, and then it would descend, okay? And descending means it's gonna fly downwards basically, okay? So let's just say I draw that glider here again, okay? And we're going to draw a right angle triangle like this, okay? And this glider here is moving down this way, right? And he's going to land right here, right? So this word altitude, what that means is it means a vertical height of 1.5 kilometers. So there's my altitude of the plane. It's 1.5 kilometers above the ground, okay? And to land, it descends at an angle of 80 degrees to the horizontal. Okay. So what this means is this is our horizontal. So make dotted. And if this is our horizontal line, it's going to descend at 18 degrees to it. Okay. And now you'll notice that this angle is not inside the triangle. What we call this later on is an angle of depression, okay? Which means it's sloping downwards, all right? And the plane is going downwards. But we can actually find the angle inside the triangle by using alternate angles. So this angle here matches what this is here. So I'm going to write that right inside there for you. Then, how far must the glider travel before landing? So if it's asking for how far the glider is traveling, well, it's traveling in this direction. So we're trying to find out what the hypotenuse is opposite the right angle. Whereas what we've got here is opposite the other angle. So call that O in this case. So using our mnemonic Sakatawa, you know that O and H belong to SO, which resembles sine ratio. So we're going to have the sine ratio equal to the opposite side over the hypotenuse. That is 1.5 over the hypotenuse, which we don't know. We'll just call that x. So we'll say 1.5 over x. Oh, but you know what? I made a mistake because sine theta is supposed to be sine of 18. We've got the angle there already. So because we have the x on the denominator, we should switch this around with the other side. So x equals to 1.5 over sine of 18. So typing that on our calculators gives us x equals to 4.85. And because the question says to round to the nearest 0.1 kilometers, okay, meaning that it's the number right after the dot. Okay, so we've got a number right after the dot. We want to either keep this or change this, and this depends on this number here. So that number, because it's above 5 or 5 or above, sorry, that is going to change that to a 9. So we're going to say that x is approximately 4.9 kilometers. Right, let's move on to question 9. So here in this case, a boat is anchored by a rope 5.5 meters long. If the anchor rope makes an angle of 23 degrees with the vertical, calculate the depth of the water. Okay, so, so what does this actually mean? We've got a boat here. Okay, let me just draw that boat. Okay, it's on top of the water, right there. Okay, so here's my water. And apparently it's anchored by a rope 5.5 meters long. And the rope makes an angle of 23 degrees with the vertical. So if I was to draw a right angle triangle right here, okay, right there. Okay, there we go. This is a right angle triangle. Well, that rope there is 5.5 meters long. Okay, so it's going from the boat here all the way to the anchor right here. So the anchor is like that. Okay, just trying my best to draw one like that. So that anchor is 23 degrees with the vertical, which means it's right here. Okay, since this is the vertical. Okay, so our angle here would be 23 degrees. Whereas this angle is called the angle with the horizontal. So we want to calculate the depth of the water. So the depth of the water is basically this distance here, which we'll call x. Okay, so that's how deep the water is, since this is where the bottom of the sea is. Okay, so what do we have? This edge here is right beside the 23 and the 90-degree angle, which we'll call the adjacent side, and opposite our 90-degree angle is 5.5, so we'll call that the hypotenuse. So because we've got A and H, let's have a look at our mnemonic Sakatawa, and we have A and H belonging to ka, so that represents the cosine theta. So cosine of the angle 23 degrees is equal to x in this case, which is our adjacent side, over 5.5. So if we now multiply both sides by 5.5 to find out the value of x, okay, and we do that because x is on the numerator already, so we have to get rid of that, so we do the opposite. So x will now equal to 5.5 times cos 23. 5.5 cos 23 is going to give us 5.0627, so on. And because they want us to round this to one decimal place, well, that's going to round to 5 points. Let's see, if this is one decimal place that we have to round to, that number 6 is above 5, so that number 0 must go up by 1. So it's 5.1 meters. Okay.